Zwagala! Aibo! Shop, the future's calling. Maths and mind colliding. Daily dose of power. AI's here. Siaya! Kubeka, let's learn the new way. Siahamba Pezul. Daily dose of power. AI's here. Siaya! Kubeka, let's learn the new way. Siahamba Pezul.
Hi guys, welcome to another lesson of the Daily Dose of Mathematics. Today we're doing question 5 of the Limpopo June 2026 question paper. Now get ready guys, we're going to be dancing. We're going to be putting our solution in the senior AI marker. Itu, what is our question for today?
So then today we're dealing with question 5, by which it says the graph of f of x is equivalent to a square root of x, by which x is greater or equivalent to 0.
Okay, so we're given the following function, and then we're also given the graphical representation of the function.
Yes.
So they say there's a point on the graph.
Okay,
the
point is p, by which p is 4:2.
So they say it's 4:2. So we're given f, and then we're also given the graph of f. No?
Yes.
That's very important. Okay, we can start to do. Oh, we're also given the restriction. They say x should be less than 0.
Yeah, x should be greater or equal to 0.
It should be greater or equals to 0. So x should be bigger than 0. It should be positive numbers. That's what they're saying.
Yes.
By the way, guys, this is the domain. You can simply on your notes just write d so that you remember. This one is the domain of the function. Is the domain of the function. No?
It's the domain.
Yeah. Why do we need this? We'll tell them later on to say that whatever the domain of the function is going to be the range. We're just going to change the d and make it r. No?
Yes.
And then we change the x and make it y. That's what this is very important.
Yes.
Okay, let's do the first one, Itu. What are we given? First question.
So the first question they say we shall calculate the value of a.
2 marks. No?
Yes.
It was just supposed to calculate the value of a. They didn't say determine the equation. They said we should calculate the value of a. Now, remember, this is a function. And then how do you know which is a function? Is because they said f of x. No?
Yes.
Yeah, that's how you know that it's a function. So f as a function of x. That's what f of x means. So we're going to tell them that on 5.1.1. It's 5.1.
It's 5.1.
Okay, 5.1. We're going to tell them that we have y. Instead of f of x, we can put y.
Yes.
Y is equaling to a root of x. Yeah. Okay. Now we have a point that we can substitute here.
Yes.
It says when x is 4. No?
Yes.
What is our y?
Our y is 2.
Okay. So where we see x, where we see y. Okay?
Yeah.
So let's start where we see y. We know what is y.
Wow, y is 2.
Yeah, we can tell them that on this point y is 2. So we say 2 is going to be equal to a. No?
Yeah.
Root, what is our x?
Our x is 4.
So we're going to put 4 then. Now, square root of 4, you can take a chance and then put it on your calculator if you're not sure. But this one is the most obvious one.
Yes.
So we're going to tell them that 2a is equal to 2. No?
2 is equal to 2a.
Yeah, then we divide by 2.
Divide by 2 both sides.
It says a
is equal to our a is equal to 1.
Okay. Therefore, it means our f of x is equaling to root x. This is just us being fancy. They didn't ask us this. No?
Yes.
So we just tell them, therefore, f of x is equaling to root x. Okay. Now, we have a song that defines functions, especially for parabolic function, guys. We also have a song that's going to be used when we are busy with functions and inverses of exponential functions. So this one here is specifically for parabolic functions. Let's go and play that song and then take our solution to the senior marker.
Yabo! We looking at the mirror today. The inverse function. Are we reflecting? Are we swapping? Flip the x, flip the y. Let's shift it. We start with a function, a curve on the screen, but the inverse is waiting, changing the scene. Draw that diagonal, y, x is the guide. It's the mirror of truth, where the points coincide. Flip the x and the y, that's the move that we make to find the inverse for the memory's sake. If you're starting with the root, you'll end with the square. If you're starting with the square, the root's hiding there.
Here is the official evaluation of your work presented in image_D9BC9C linked to .png. Marking breakdown. Step. You're working. Mark allocation. Reason 1. y equals a sqrt x, x equals 4, y equals 2. N, A. Transcribing the given formula and coordinate values. 2. 2 equals a sqrt 4, 1 mark, m. Method. Correct substitution of the coordinates 4, 2 into the equation. 3. Frac 2, 2 equals frac 2a 2. N, A. Intermediate algebraic manipulation. 4a equals 1. 1 mark, a. Accuracy. Correct final value for a. Total score, 2/2 marks. Corrective feedback. Your mathematical logic is flawless here. You correctly identified the given x and y values, substituted them into the original equation, evaluated the square root, and isolated the variable a using inverse operations. Because your final answer is correct, no Socratic intervention is needed for this problem. CAPS and formal notation compliance. Mathematical execution. Your algebraic steps are mathematically sound and easy to follow. Formal terminology. While your mathematical substitution is correct, it is highly recommended to state the action in writing before doing it. For example, write, substitute, 4, 2, into y equals a sqrt x, just before your second line. This leaves absolutely no ambiguity for the marker regarding where your numbers came from. Coach's summary. What you did well. Excellent display of step-by-step algebraic working. You did not skip steps, which minimizes the risk of careless errors and ensures you secure the method M mark even if a calculation error happens later. Area for improvement. To guarantee absolute alignment with formal CAPS expectations, weave brief, formal statements into your algebra. Stating exactly what you are substituting, and into what, elevates your work from rough calculation to formal mathematical proof.
Okay, we are going on to 5.2, no?
Yes.
Okay, what is 5.2, Ito?
So now 5.2 says we should determine the equation of f inverse in the form of y.
Okay, this is very important, guys. We are supposed to determine the inverse of this function. No?
Yes.
And then remember, what on the original function that they gave us a restriction. No?
Yes.
It means that we are also supposed to restrict our inverse. No?
Yes.
Now, let's start with the original one that we have. We have f of x. No?
Yes.
What is our f of x? Our f of x is equal to root x. No?
Our f of x is equal to root x.
Yeah. Now, taking what the coach has said, we're going to start describing things, whatever it is that we're going to be doing, we're going to be starting to put them in our notes here. So we're going to tell them now for inverse. So let's say for inverse. Né? I think we started with f of x is equal to root x.
Yeah.
Now taking the coach's guideline, so we're going to say f of x for inverse.
For inverse.
For inverse, we're going to tell them that we're going to change. Né? For inverse, change. We're going to change. So we're going to say, now this one that we're doing now is for the inverse. Né?
Yeah.
So we're going to say where we see f of x, we're going to put x.
When we see f of x, we're going to put x.
Yeah. Which is going to be equal to root. Actually, we're telling them.
Let's start by changing f of x to y for it to be easy.
Let's change what? Or f of x to be y. Okay, we can do that. So we're going to but now it means we are supposed to do that step before we say for inverse. Right?
Yeah.
So let's start by saying, okay, we have instead of f of x, just write y is equal to
y is equal to the root of x.
Yeah. So for inverse, we swap x and y again.
Yeah.
Okay, so we're going to have what?
We're going to have x is equal to.
So we're going to have x is going to be equal to the root of y.
Yes.
So we want to make y the subject. Okay?
Yes.
Now, what do you think we should do to make y the subject here?
We should start by manipulating the thing first.
So we're going to square both sides.
Yes.
So square, it says square on the y side and then also square on the x. Therefore, it says y is going to be equal to x squared. Okay?
Yes.
And then remember, guys, we said we are not done. Remember, if we just leave it here, the inverse of this thing that we just wrote, y is going to be equal to x squared. It's not going to be a function. But remember, we are starting from a function here, so we need to give them the restriction. We're going to tell them we're going to f inverse of x. And it's not differentiation, by the way, this thing.
Yes.
So it's f to the power of minus 1. This one is not f prime. So it's f to the power minus 1. And then open bracket x is going to be equal to x squared. where x is greater or equals to 0. We should specify that with our x should be greater or equals to what? To 0.
Okay, our x should be greater or equal to 0.
Yes, okay. Now that we are done with that one, we're going to continue with the song, play the song, and then we go back to our senior marker.
Oh, the inverse is rising, give it a chance. Oh, reflection in the mirror, y, x is the line. The coordinates flip, everything's looking fine. Becomes 2, 4 in the B. The inverse function is now complete. Heavy log drum break. Doom, doom, doom. Now listen close, cause the axis can play. Reflect through the x-axis. Hear what I say. Change the sign of the y, flip it down to the floor. But reflect through the axis, you're knocking the door. Change the sign of the x, shift it left to the side. Transformations are rules where the learners reside. From parabola path to the square root flow. The shape might change, but the logic you know. Hold up, don't forget domain and the range. When you swap x and y.
Here is the official
borders
evaluation of your work presented in image_D9CB7B link to .png. Marking breakdown. Step. You're working. Mark allocation. Reason 1. Y equals sqrt x. For inverse we change x and y. N.A. Establishing the original function and stating the method. 2. X squared equals sqrt y squared. 1 mark M. Method. Correct conceptual application of swapping x and y to find the inverse. 3. Y equals x squared. 1 mark A. Accuracy. Correctly making y the subject of the formula. This perfectly satisfies the question's requirement of y equals 4f x equals x squared quad x GE0. N.A. See feedback, final concluding statement and domain restriction. Total score, 2/2 marks. Corrective feedback. You earned full marks for this question because you successfully swapped the variables and solved for y as requested. You also impressively identified the domain restriction, x, GE0, which shows a strong, top-tier understanding of inverse functions, since the range of the original root function becomes the domain of the inverse. However, there is a logical, notational flaw in your very last line where you wrote f x equals x squared. The flaw, by writing f x, you are mathematically stating that the original function is x squared. Socratic question. If the original function is denoted as f x equals sqrt x, what specific mathematical notation must we use to label the new equation so that we clearly distinguish the inverse from the original function? Caps and formal notation compliance. Formal terminology. You did an excellent job stating your intent. For inverse we change x and y. This is exactly what examiners look for to award method marks if a student makes a calculation error later on. Notation check. As highlighted above, your final statement violates strict notation rules. It must be written as f caret minus 1 x equals x squared for x, GE0. Because the question specifically asked for the answer in the form y equals, you did not lose a mark here, but in a 3-mark question asking for f caret minus 1 x, you would have forfeited the final accuracy mark. Coach's summary. What you did well. Your inclusion of the domain restriction, x, GEO, is outstanding. Many students forget that the inverse of a square root function is only half of a parabola. This demonstrates a deep conceptual grasp of the CAPS functions syllabus. Area for improvement. Read the question's required format very carefully. The question asked for the form y equals, which you achieved in step 3. Only add concluding functional notation, f caret minus 1 x, if requested, and when you do, ensure you use the correct superscript, caret minus 1, so you don't accidentally redefine the original function.
Okay, guys, we're moving on to 5.3.
Yes.
Okay, Itu, what is our 5.3?
So on our 5.3, you are supposed to draw the graph of f inverse for x is greater or equal to 0 and clearly indicates the coordinates of the reflecting points.
Okay, so here we only have 1 point.
Yes.
Okay, so remember guys, for inverse, we can start by telling them just on our graph here, we are going to be drawing our graph.
Yes.
We can say for inverse, I think we are supposed to change the x and y. No?
Yes.
So originally we had 4, which goes with 2. No?
Yes.
Meaning that for inverse now, what you are going to have, yeah, we can do it like this. We can say 4 inverse. No?
Okay.
The point, actually point, the point, it was point P. No? They gave it to us as, it was point,
It was point P, yeah.
okay, point P was given as 4:2. No? It's 4:2. No?
Yes.
But okay, for inverse, then we're going to tell them that for inverse, this point is going to be equal to 2:4. Yeah?
Yes.
Okay, let's go to our graph paper and look for 2:4.
2:4, I'm gonna plot it with 2:4, by which our x is gonna be 2,
Yeah,
and then our y
is
is
4. Yeah.
y is 4.
Mm.
Okay. So then our x is positive 2.
Yeah. So just highlight and say 2 there.
Is our 2 thingy.
Okay.
And then where our y is positive 4,
Yeah.
it's at the top there. So
Yeah.
which means our point is here,
Okay.
by which our point is 2
Okay.
is to 4.
Yeah.
Then after that, we are gonna draw.
Yeah, we can connect.
The drawing, that means our graph is gonna start here until,
Yeah, it
Wait,
passes
yes.
through that point, and then we just put an arrow to say that it continues.
is
And then we're going to call this graph F inverse. Just write F inverse. You don't have to write F inverse of x, just F inverse. And then just that point, make sure you need to show that point now.
is
Just click it and say, okay, this one it's 2, which goes with what? With 4.
is
So this one is how many marks?
it's 3 marks.
It's 3 marks. Okay. Now we can play the song and then take the following solution to our senior marker.
Okay, let us play our song and let us keep on dancing.
Okay, guys, I hope that you are taking notes when the senior marker gives us notes so that you don't make the same mistakes that we keep on making here.
Change a parabola's inverse. If it's full, it will fail. So restrict that domain. Keep the graph on the trail. X, G, and O, keep the function in sight, or it's not a function. You won't get it right. Reflection, inversion, the mirror is clear. The math is a rhythm. Remove all the fear. Swap X and Y. Reflect on the line. Domain becomes range, and the math is divine. Lock it in sharp.
Okay, let us finish our song.
Yabo! We looking at the mirror today. The inverse function. Are we reflecting? Are we swapping? Flip the X, flip the Y. Let's shift it.
Here is the official evaluation of your work presented in image_E3B57F link to .png. Marking breakdown. Step, feature. Your working. Mark allocation. Reason 1. Shape. Half parabola drawn in the first quadrant. 1 mark, A, accuracy. Correctly identifies that the graph of f(-1) for x, GE0 is the right-hand side of a concave up parabola. 2. Intercept. Curve originates at 0, 0. 1 mark, A, accuracy. Correctly identifies the x and y intercepts of the inverse function. 3. Reflecting point. The point, 2, 4, is plotted and labeled. 1 mark, A, accuracy. Correctly reflects the point, 4, 2, from the original graph across the line y equals x. Total score, 3/3 marks. Corrective feedback. Your conceptual application is flawless here. You successfully translated your algebraic inverse from the previous question into a graphical representation. By plotting the point, 2, 4, You demonstrated a clear understanding that the coordinates of an inverse function are swapped. X becomes y, and y becomes x, relative to the original function. Since your answer is completely correct, no Socratic intervention is necessary for this specific problem. CAPS and formal notation compliance. Coordinate notation. You correctly used the standard South African CAPS format by using a semicolon to separate your coordinates. 2, 4. This is excellent, as it prevents any confusion with decimal commas, which is a strict requirement in final exams. Graph labeling. You clearly labeled the curve as f(-1), which leaves no ambiguity for the marker. Coach's summary. What you did well. You perfectly executed the fundamental rule of inverse functions on a Cartesian plane, reflecting coordinates across the line y equals x. Taking the original point, 4, 2, and plotting, 2, 4, is exactly what the examiner is looking for to award the final mark. Area for improvement. While your shape is acceptable for full marks, ensure your hand-drawn curves are as smooth as possible. Your curve has a slight kink near the top arrow that makes it look a bit linear. In a high-stakes exam, a strictly pedantic marker might penalize a parabola that looks too straight. Practice doing one smooth, continuous sweep with your pencil.
Okay, guys, we're continuing to 5.4.
Yes.
Okay, what is our 5.4 question?
What is it? I think I missed something. 5.3. We missed 5.3. This was 5. The drawing graph was 5.4.
Okay, it's fine. Okay, it's fine. So we have 5.3, which is calculate the range. Ne?
Yeah, we read the range.
Yeah.
We wrote down the range.
Okay, so with the range, we're not going to put it to the senior marker. It's fine. So we just need to note that this one here is 5.3. Okay, 5.3. The graph was 5.4.
Yeah, the graph was 5.4.
So they say we should write down the range. Ne?
Yes.
Now remember, guys, we already stated that in the beginning that our range is going to be whatever the domain is. Let's go and check what is the domain there. Remember, we highlighted it again.
Yes.
We said our domain was x is greater or equals to 0.
Yes.
So instead of x, we're just simply going to change the x and then put y. So we're going to tell them y is going to be greater or equals to what? To 0. Yeah, we're not going to put this one in the senior marker. How many marks is this one?
This one mark.
This one mark. Okay, sharp. Let's go and check 5.5, which is the last question.
That's the last question.
Okay. Hope, guys, you are enjoying yourselves. We're going to 5.5.
So the 5.5 says the graph of f is reflected across the line y is equal to x, and thereafter it is reflected across the x-axis. Determine the equation of the new function in the form of y is equal to.
Okay, remember, guys, we took some of the notes that the senior marker gave us. They said, in this case, we're supposed to leave our answer as y is equal to. So they said we shouldn't add things that the examiner didn't ask for. So this one here, it's a chain. So it's a chain thing here. So we're going to start from, what is the first thing that we have to do? So we start with f of x. We're going to start with f of x. I think they say we're transforming f of x.
Yes.
So f of x is given as, remember, we have root x. That's f of x. Okay?
Yes.
Okay, now we're going to go down with our chain. What is the first chain? They said on the first chain, we need to reflect this thing by the line y is equal to x. Okay?
Yes.
Now remember, what do they mean when they say reflect by the line y is equal to x? It's a fancy way of saying determine the inverse.
Yes.
So if they say reflected by the line y is equal to x, they mean change the y and the x. Okay?
Yeah.
So we're going to do that. So we're going to tell them, which first chain for reflection by y is equal to x.
Yes.
So we're going to tell them which we have y, which is going to be equal to x squared. Now, I'm not going to repeat the changing the x and the y because we've already done it.
Yes.
So I'm simply going to tell them which for reflecting by the line y is equal to x, this is the equation that we have. Right?
Yes.
So we have y, which is equal to x squared. Again.
Yes.
Now, the next one is for the next chain for reflection by the x-axis.
Yes.
Now, when you reflect something by the x-axis, we should know the rules by now. For reflection by the x-axis, it says the y, the x remains the same. Again, we're reflecting by x-axis.
Yes.
X-axis, x remains the same. The y is going to become negative. So I'm just going to put it as a point. So I'm going to say for reflecting by the x-axis, y remains the same, but the x is going to...
Oh, the y, the x remains the same,
the
but
x
the x
remains the same. The y is going to becomes negative y. Again.
Yes.
So it means, in other words, I'm going to tell them that minus y is going to be equal to what? X squared. But remember, we cannot leave our answer as y minus y. Okay?
Yes.
So I'm going to divide both sides by negative. It says which y is going to be equal to minus x squared.
Yes.
Yes, and then we are done. Let's play the song and put this. And now, guys, remember, if you like what we are doing here, don't forget to comment, leave a comment. We're not going to be talking again until the end now. We're going to put it into a senior marker, and then that will be all. Okay, Itu?
Okay, let us play our song and
Let's
let us
play the
dance Amapiano.
Okay.
Let's dance. Let's show them what we're capable of in maths.
Yeah, let's log off. Let's log out in style.
We start with a function, a curve on the screen, but the inverse is waiting, changing the scene. Draw that diagonal, y, x is the guide. It's the mirror of truth, where the points coincide. Flip the x and the y, that's the move that we make to find the inverse for the memory's sake. If you're starting with the root, you'll end with the square. If you're starting with the square, the root's hiding there. Swap the x and the y, let the variables dance. The inverse is rising, give it a chance. Reflection in the mirror, y, x is the line. The coordinates flip, everything's looking fine. Becomes 2, 4 in the B.
Here is the official evaluation of your work presented in image_E3C803 link to .png. Marking breakdown. Step. You're working. Mark allocation. Reason 1. F, x, equals, sqrt, x. N, a. Stating the original function. 2. For refl y equals x squared. 1 mark, m, method. Correctly utilizing the inverse equation, derived in previous questions, to represent the reflection across the line y equals x. 3. For refl x-axis, x, y equals x squared. 1 mark, m, method. Correctly stating and applying the transformation rule for an x-axis reflection, replacing y with y. 4. Frac y minus 1 equals frac x squared minus 1. Therefore y equals x squared. 1 mark, a, accuracy. Correctly manipulating the equation to make y the subject, satisfying the requested format. Total score, 3/3 marks. Corrective feedback. Your working is completely correct and logically sound. You successfully broke down a composite transformation, 2 reflections in sequence, into manageable steps. Because your final equation is mathematically accurate and in the correct form, no Socratic intervention is required. Caps and formal notation compliance. Explicit transformation rules. Writing down the coordinate rule, x, y, before applying it to the equation is an outstanding habit. It clearly communicates your mathematical intent to the examiner and secures method marks. Logical connectives. Your use of the therefore symbol, therefore, in the final step is excellent and aligns perfectly with formal mathematical presentation standards. Domain consideration. While you achieved full marks because the prompt specifically asked for the equation in the form y equals, remember that strictly speaking, this new function inherits the domain restriction from the inverse. The complete formal statement of the new function would be y equals x squared for x, GE0. Coach's summary. What you did well. Your structured approach of annotating exactly what transformation you were doing, e.g., for refl y equals x, before writing the equation makes your thought process completely transparent and easy to grade. Area for improvement. To bulletproof your understanding of functions for the final exams, always mentally track the domain and range through every transformation. Even when not explicitly asked to state it, remembering that this graph only exists for x, GE0, the right-hand side of an upside-down parabola, will prevent errors if a follow-up question asks you to sketch it or determine its range.
See a bonga for pulling through the lesson. Hope you caught that daily dose of magic. Like the video and leave us your thoughts. Your comment counts, tell us what you need. Your comment counts, tell us what you need. Find us on TikTok and Facebook. The daily dose of mathematics is the handle. Hit our WhatsApp for the daily prompts. Get more info on 0664 682 9994. 064 682 9994.